In many real-world problems, we don't just predict numbers, we make decisions. For example, given a student's marks, attendance, and extracurricular activities, we might decide whether to admit them or not. This is called a classification problem. In this video, we'll learn how a decision tree classifier works and how it chooses the best questions to split the data and make accurate decisions. Suppose we have this data. For each student, we know their marks and whether they were admitted or rejected. Our goal is to find patterns in this data and make good decisions for a new student. A decision tree is a simple yet powerful model. It asks questions based on the features like marks and splits the data step by step to make decisions. In a decision tree, we can split the data using any feature, whether it's marks, attendance, or extracurriculars. All are the options. But we want the split that makes our job the easiest, one that cleanly separates admit and reject. So for now, let's pick marks and see how good splits based on marks can be. Now when it comes to picking the best feature and the best place to split, there are generally three common approaches. But in this series we'll focus on information gain first because it's simple, intuitive and widely used. Let's start with marks feature. We focus on the marks and the final decisions, which is admit or reject. Before splitting, we first calculate the parent entropy, which tells us how mixed the overall data currently is. A higher entropy means the data is more uncertain or disorganized. Once we know the parent entropy, we explore how splitting by marks can reduce it. Since marks is a numeric feature, we first sort all the mark values. Then, we find possible midpoints between each pair of neighboring values. These midpoints act as candidates for splitting the data into two groups. One group with marks below the midpoint and another with marks above it. Each candidate split is then evaluated to see how much it reduces the uncertainty compared to the parent dataset. The idea is simple. The better a feature splits the data into clean groups, the more useful it is for building the decision tree. Now let's go through each possible split one by one. First we try splitting at 35. We separate the students into two groups, those scoring less than or equal to 35 and those scoring more. Then we calculate how pure each group is using entropy. We'll substitute the probabilities into the formula and find the weighted average entropy after the split. Next we try splitting at 56. Again we create two groups, calculate their entropies and compute the overall weighted entropy. Similarly, we check at 78.5 and then 88.5. For each split, we are asking how much uncertainty remains if we split the data here. In the end, we'll pick the split that reduces uncertainty the most, that is, the one with the lowest entropy. The lesser the entropy, the higher the information gain is. And we want to choose the data point which has the highest information gain. As we did for all the data points in the marks feature, similarly we'll do for all the data points in all the features. And then whichever has the highest information gain, we'll choose that feature and move forward by making it the root node of our decision tree. This is how simple information gain is. In the next video, we'll see Gini impurity and the code for decision tree classifier.